Kubernetes on the Raspberry Pi has been around for about 2 or 3 years, and in that time, storage has generally stayed either slow, unreliable, or cumbersome. So most people have looked at doing stuff like NFS, but NFS has some performance issues. One of the first things people try to run on a Raspberry Pi's K8's cluster is Prometheus, and Prometheus really can't reliably use NFS as a storage. So people then move on to using something like local disk, which is you can literally have the container just write to a local disk on a node. The problem with that is if that node goes down, that data is lost. So your workloads cannot migrate. Um, there's been other solutions out there as well. I did a POC with GlusterFS a while back, um, but most of anything else I had seen is extremely cumbersome. I don't want to set up an external Gluster cluster, and I don't want to run it containerized because that has its own issues.
So often what problems people have had is just any kind of storage solution is that has performance and reliability and ease of set and are easy to set up didn't really exist until recently in the last year, I would say. Rook, a storage operator, has gotten some traction in the world of Kubernetes, a cloud native storage orchestrator, and that can be used to provision Ceph clusters hosted on Kubernetes. And as of this July, they started to push ARM64 images for their CSI drivers. So this is the first time that a Raspberry Pi user can just follow their docs and build out Ceph clusters on Pis. Before this, we were I there were some I found some pretty sketchy at best manifests on GitHub where people got the flex volume drivers to work, but they were inconsistent results there. And there were some OS level requirements that were not really well documented. So here is my cluster. I have 3 workers that are also storage nodes, one master, and then these are 2 nodes in AWS that I use for external load balancing. So let's see. I did this on K3s version 117. This is a little old, and I've noticed that there are some issues if you try to do this when the major release is off on nodes. So I actually had to downgrade one of these workers back to 117. I've been meaning to do an update, but I haven't gotten around to it. Um, and then, let's see. Rook-ceph. So pretty much everything that is related to the storage orchestrator are scheduled on these storage nodes. This is how Red Hat OpenShift kind of sets up as well. Is the Red Hat OpenShift container storage is based on Rook-ceph, and I kind of ripped off a little bit of the setup and just mirrored it with Raspberry Pis with these dedicated storage nodes. So, if I were to add 3 nodes that I wanted to use just for storage, I could throw this storage role on it and on them, and then these services will be automatically scheduled. So these nodes are workers 1 through 3. Is they're running the Ceph orchestrator and a bunch of the underlying software, and some other workloads. It is a little high on memory. You can see workers 1 through 3 are they deviate between like 60 and 70% memory. And some of these pods do take up quite a bit of memory. That said, this is this is pretty much an unmodified deployment of Rook-ceph. I pretty much to the T followed the docs and did the default. Just all of the Ceph, what is it called? The RDB pool and the Ceph FS pool. These are all default settings. So it's definitely possible to slim this down for Raspberry Pis, but I just wanted to point out that you can follow the docs to the T now and get a cluster up on Raspberry Pis. These are three. So these storage nodes are Pi 4 gigabytes of RAM, and it's these $9 Amazon flash drives I bought. So that's what the storage is based on the that's what it's on top of. These are running Ubuntu 20, I believe. To show wide. One's on 20, but Ubuntu 19.10. This is on 20, but the OS doesn't really matter, I guess. Well, it does matter. It has to be on Ubuntu. You can't do it on top of Raspbian or Raspberry Pi OS. At least you weren't able to originally. I'll have to double check that. But the RDB model, the RDB kernel module, is not included in the current build of Raspberry Pi OS. So if you want to host the storage, I'll try to. I have my master's on Raspbian, so I'll try sometime to bind a volume to it. My master just only runs the control plane, so I don't. I haven't really tested that yet. Okay, so I've torn down my Rook-ceph installation. To uninstall, you pretty much delete manifests in the order you created them. So I had this storage class directory. I deleted all PVCs that were created from these storage classes, and then I deleted the storage classes. Then I deleted the Ceph cluster, and then common and everything under that. Once you delete all the Kubernetes stuff, you have to zero out the disks. So you in each node rm varlib rook zap. This was actually SCA. Do an SG just zap all, and then it said run blk discard, but this didn't work through an error, and I'm just gonna hope it works. And then what you should see before you create all of the objects is here I just did an Ansible shell lsblk on my storage nodes, and you can see that every one of them SGA has no partitions and is just a disk. All right. At the time of this recording, Rook version 1.5 is the latest. If you want the exact manifest that I'm going to be using, you can go to their GitHub. You can go to the 1.5 branch, Rook cluster examples Kubernetes Ceph. I took these files and then I copied them into this directory. I also self-host all of my live manifests. This is going to be this. Let's see. -io because .io is taken, but this IGO Kubernetes repo also holds everything I'm using to my best effort. There's some stuff I haven't checked in yet, but so let's see. So starting out, create the crds.yaml and the common.yaml. crds.yaml is the custom resource definitions, so that's just objects that that the operator uses to take in just data from users. It allows us to create our custom resources. And then common.yaml is basically all the service accounts in the namespace. So crds.yaml, I think I already reapplied this. And common.yaml. So I made one small change to my operator.yaml. I gave it a node selector to only run on my storage nodes because I want all of my storage related loads as far as running the cluster to be scheduled on nodes that have the role storage. operating YAML unchanged because I already applied that. I already recorded this once since my mic muted. And you can see worker 3. I know it's here due to the node selector because let's see, because worker 4 is a Raspberry Pi 8 gig, and these 1, 2s, and 3s are 4 gigs. So pretty much anything I make, anything new I deploy, and I just added this to the cluster. So anything I create, I know it's gonna get scheduled on this 4 because the 4 has like 4 times as much available memory because these already have loads on them. So they had like 2 gigs available, and this is just like out of the box, and it has 8 available. So I know that's working. But let's see, create the CRD. Alright, so the next thing to do is create our cluster. So let's see, cluster.yaml, let's see, I gotta make sure, yes. Alright, so the cluster.yaml defines the actual Ceph cluster. So from what I understand, and I am no expert, but Ceph is a cluster of disks, and then Ceph can serve different kinds of storage from that cluster. It can do file, block, or object. So this Kubernetes object defines the Ceph cluster that's going to be created from the disks that we specify. In our case, these are $9 flash drives from Amazon. They're 128 gigs. I've never benchmarked them. They don't do anything fancy. They don't have UASP or any of that stuff. I think they're pretty bad, and they get kind of hot and smell bad sometimes when there's a lot of work going. But I'm just doing this to prove a point of how easy it is to get this up now. So let's see. So most of these I'm not going to touch. These are all pretty much default. I plan on optimizing this down the road because I think we can really slim its profile and make this the go-to storage for Kubernetes on Raspberry Pis. But for now, we're just going to do default everything in the branch. There's a couple things I did change to work with how I have things set up. So I did, let's see, I enabled the dashboard, but enable monitoring. I couldn't get this to work though. Rules and namespace, Rook-ceph, network. Didn't touch any of these. Placement. Okay. So I added a node affinity rule and tolerations. Even though there's no taint, I can actually delete this. What you want is this node affinity rule required during scheduling, ignored during execution. And this basically says, only run the service pods on storage nodes. And then for storage, use all nodes false, use all devices false. Because we're just going to manually call out our workers and their devices. So these are the 3 node names for our storage nodes, and these are the devices. I plan on doing more work kind of messing with this. I think you can use UUIDs for this because it gets a little weird when you have multiple drives. This worker 1, I used to have another flash drive in it that was used for the Rancher local storage provisioner, and it would trade IDs with my Ceph one. Like one would be SDA one boot, and then one would be SDB the other boot. So it was a little inconsistent. So I just unplugged it. But you can definitely, you can definitely, look, he's doing it right here. Yeah, desk by ID. So yeah, I can. It doesn't have to be like this. I can make this better. I plan on making this better, but I'm just doing kind of an MVP thing. Disruption management. I don't think this does anything. This is like an OpenShift thing actually, but. And let's see, health checks, and that's it. So basically, I manually add my nodes, and I give it this node affinity. And let's apply it, and let's see if it blows up, because I did not, I haven't done a redeployment yet. No, that's not it. Cluster.yaml. So when I first did this deployment, things went a little crazy, and I expected it to go crazy, and this took over 10 minutes, and this video is going to get cut down because it's because it would take forever. But you can see cluster creating is progressing. These pods are creating. This should go pretty fast because I didn't prune the images on any of these nodes, so the images are. I don't have to download any images. They're already on the node, so the container should just start. So maybe we can just do this live. You'll know. And in my experience, most of for troubleshooting, the operator logs are helpful. And this appears to not be on fire, which is kind of what you hope for with Kubernetes. That's kind of the go-to. Prepare worker OSD. This is actually, I'm doing a reinstall here, so I think if I'm going to see anything like screwed up, it's going to be here, because I didn't do anything right. Well, in the event that I did not zero out these disks correctly. But it looks okay. Okay. Ooh, okay. So one indicator that I think this went well is cluster successfully created and health okay. And this is cool. This is actually a Ceph API call when you see health okay. I'll go into this later. But so to see the health of your cluster, you see how the cluster was created successfully. I think I saw some weird stuff when I did this the first time, and I think part of it was just kind of race conditions having weird outcomes, because I'm using SD cards as the OS file system on these workers, and I think SD cards in 2020 are pretty slow, and I think that random things were not happening in the synchronization that the operator was expecting, because I was seeing some failures and this was not healthy the first install I did. But the second install, with instant Docker pulls, essentially, because I already have the images pre-pulled, this appears to be working a lot smoother. So if you see anything, I don't want that. You scheduled? Container creating. Yeah, okay. So that's it. Holy crap. Okay, nice. It worked. Right. So here it's clusters up. If you want to get the status, you can see it was created successfully. Another thing included is this toolbox, the Rook-ceph toolbox. Which is just a CLI. It gives you the Ceph CLI. So, and this is useful for looking more at the Ceph level of things, for just to see what's going on. Okay, get pods -n Rook-ceph. How is my toolbox? Pod -o wide grep tool, I guess. Yeah, so And let's check. Let's get a look. Ceph status. That's the only command I know. I'm not an expert on this stuff. I'll be back. I'll come back to make this run better later. But and you can see health is okay. We have quorum, 365 gigs available. 3 gigs used. That's for the file system stuff. And yeah, we have a Ceph cluster. That's pretty cool. So let's take a look at these. Let's take a look at this resource consumption. So this is right out of the gate. This will grow higher as more things get scheduled. I haven't created I haven't created RDB or file system clusters, or yes, Ceph file clusters, and those consume resources themselves. So let's do that now. So let's do some block storage. So storage class rdb.yaml. I don't know what RDB means. I just know this is for the block storage. Let's look at the manifest that we're creating, and we can do this. Let's look at it here. It's a little prettier. So the first thing you create is a Ceph block pool object. Replication size is 3. That's like this is a production kind of thing. On my cluster, I'd probably set this to 2. You'll squeeze a little more memory out of your cluster. I think that's what this is for, is replication. So there's 3 disks, and the data is replicated on each disk. So if you microwave one of your Raspberry Pis and add a new one, that data will replicate, and then you can have the same reliability. That's more relevant when we're using servers that make you money. So, and then require safe replication size once again. And then the storage class, let's see, I did not modify. I did not modify any of this. So this is straight out of the repo. And this guy seems to be doing okay. So I think, let me see here. I use Argo CD, and my application object for Prometheus I edited, and this is really gross. Let's do this in the browser. How about that? Prometheus, and let's do this in my browser, Argo, and go to Prometheus, and synced about an hour ago. So I edited this. Okay, get STS. I edited this to use storage class name, not a storage class, which is not a storage class. So let's tell Prometheus to request 50 gigs of storage from our new storage class. That sounds like a good way to test our block storage. So I'm just going to edit this inline. Let's see. How do you do this again? Oh, manifest. I haven't migrated all of my stuff into Argo yet. So I'm still getting to learn some of this stuff, but I do know that, and this is just a Helm chart. Let's change the storage class. What's my keyboard doing? Oh, edit. Let's change you to this. No, that's not what I want it to be. No, not that either. Let's change it to this. No, come on. Holy crap. Okay. Let's change it to this. Alright, Rook-ceph block. Let's save you. I said save. I'm doing this live. Okay, great. So this is ready to rot. And refresh, out of sync. I'm going to sync this, which is just, let's see, out of sync. The only thing out of sync should be my Prometheus synchronize. This will take a few seconds. Wait, I already have this. And now it's already been updated. Rook-ceph block. Okay, get pods dash n monitoring dash o wide. This guy's pending. And my PVC is pending. My PV's not been created. Okay. Let's see. This is live troubleshooting. This guy's healthy. Rook-ceph block. Still, oh, it's still not a storage class one. Huh. Oh wait. Oh, you know what? That's right. I think I have to delete this. And then you don't typically mess with this kind of stuff with the monitoring operator, so it might be confused. You still hanging? Okay, delete. I'm a professional, so we're just gonna do this. This is gonna get recreated pretty quickly, and now it got recreated with the volume claim template, so now it should have requested storage and it immediately bound. That's beautiful. Okay, get pods dash n monitoring. We are in container creating. And it is being scheduled on worker 4. So it is being scheduled on a node that is not running the storage services. So this is pretty cool because now one Raspberry Pi is sharing a block device to another. And it's cool to have this kind of storage performance for like, I mean, these are 128 gig drives from Amazon. I mean, this was like 20 bucks to get storage like this. And we can see we are running. Look at that. So let's take a look at have this. Let's see. Targets. This guy just came to life, but I'm scraping all of my my services. And then let's do a query. My favorite one to test with is just node load. Execute. And look at that. And the fact that we can do this query, load time 104 milliseconds. I haven't benchmarked this yet because this is just like, this is just this is basically copy and pasting the Git repo. So I'll probably try doing some benchmarks. I saw some stuff with FIO. I have a Raspberry Pi X as well, which is an 886, which is an x86 board. I want to try to do some provisioning that thing, some storage, and I'll try to benchmark these the same way that Jeff Geerling benchmarked his some of the drives that he was doing in his channel. Let's see, what do we have left? Okay. Alright, so that's cool and all, but let's say we want to to some file system storage. So to go into file versus block storage, I'm not going to go too in depth. All you really need to know for this is block storage is like block storage in Kubernetes is like handing that node or that pod, by association, a hard drive. And you can think of the limitations of block storage as you would think of a physical hard drive. So a hard drive can only be read by one pod at once. But if it's a hard drive, you're probably using like 6 gigabyte per second SATA, and you're probably getting really good performance. When we think about file storage, what's the most common kind of file storage we've probably seen in the industry is NFS. NFS is slow, but a lot of pods can read the same NFS drive. So there's some cool scalability stuff we can do here. So let's create, let's see. Let's create storage class cephfs. And let's take a look at our CR. So get -n rook-ceph cluster. Okay. I want to see if this reports on creating like clusters I request. I guess not, but that's fine. We can see that part of creating this, let's see, part of creating this this file, what is this? File system stuff. I don't know much about stuff. I know that part of this, we have to spin up pods to help serve this service. They're getting scheduled on worker 4. I plan on eventually changing this, and I also know that by default it schedules 2. One is a backup, even though when you set replicas to 1, and it's scheduling both on pod 4 on worker 4. That's kind of a waste. You don't want replicas on the same node. That's useless. That's just a waste of time. Well, a waste of resources. So this will be improved. You can check in with my GitHub and you'll see what I'm running. But we can see they're running. And one thing I forgot to mention with the toolbox, let's see, where's that toolbox? And rook-ceph. Ceph status is it should now report on the status of the myfs file system, and it will also report on my, let's see, on my, I don't know the terms. I think this is the block stuff, OSDs. I don't know, but you can see that you can kind of see what's going on the Ceph layer and check in. But now that we have both storage classes up, when we do a top nodes, you can see, no, it's actually not that crazy just yet. Huh. I'll get back to you on that one. These were, with the last install, these were pulling like, 70%. So I'm not really sure what's going on there. Pods -a. wide grep worker 4. Maybe just everything got scheduled on worker 4. Just everything on my cluster. Close. So we're rambling here. Here is a good example of the benefits of file storage. So this is a good example of when you would use file over block. So we have a PBC claim and a deployment. And the deployment is just a Docker registry. So a Docker registry is just an HTTP server where you request tarballs. That's basically it. Someone will armchair me and tell me some other things that I'm leaving out, but that's basically what Docker registries do. You can argue about that in the comments, but they so when you think about that with K8s, let's say I have three replicas. and I could have 3 replicas with storage, and I could I could do this as like a stateful set, where each one has a separate volume, and then, but those wouldn't be consistent, because let's say someone does a Docker pull or a Docker push, and it gets pushed to one pod and it's in one volume, and someone does a request for that image and it gets routed to another pod and that won't have it. So that you can't do that. So what you want is you want these 3 Docker registry pods to be pulling from the same data store or database. But it's a block. Well, it's just a folder. It's just file storage. You want them to look in the same file store for the images they're pulling, and you can use NFS for this. You can use object store, which I think is the more like production appropriate way to do this. But file storage works great. So let's deploy this. I believe I can just apply this. I think it's just worked. It's in Cube System. Okay. So here's my Cube System. It's doing its thing. Dash O wide. I got 3 replicas on separate nodes. That's cool. Last time they just all went on Worker 4 because Worker 4 is on steroids. And let's see, PVC. My PVC is bound. We're pulling. And let's see. And this is coming up. The irony is my node that's on roids is taking the longest. What's resources? And the metric server hasn't gotten a read yet on the consumption, but get pod session cube system, and we have our Docker registry. It has 3 replicas, and it is all on separate nodes. So how do we know that CephFS is working as shared storage? Well, for one, is these registry pods aren't flipping out. I mean, that's one way to know. But what if we did a Kubernetes exec IT -n cube system? I don't think this has bash. sh. Okay, cool. And but before we do that, so in this registry, you can see that for the spec of this deployment, we call for our PVC CephFS PVC, and it's named image store. And then in the container spec, in the container definition up here, it's referenced name image store, so the name that's defined down in volumes, image store mount path, and mount it in var lib registry. So we know that now we know that var lib registry and these 3 containers are all shared. So what that means is I should be able to jump into this pod, cd into var lib registry, and I should be able to touch a file that, let's say, touch archlinux.org. Cool. Okay, so now there's a file called archlinux.org inside of this file. So you see that was the CQL5D guy that was on worker 3. Let's jump into this container. I'm going to be lazy and just sjdwk. Let's jump into this container. cd into var lib registry archlinux.org. So these are these 3 replicas are sharing this directory now. This enables you to scale out. So now, if someone does a Docker pull for an Apache image, and it gets routed to this registry pod, it's going to pull it, and it's going to get put in It's going to pull it from the upstream it's proxy to, so probably Docker Hub or Quay, and it's going to pull it and it's going to save that image into varlib registry. When another user does a Docker pull for that same image, let's say their request gets routed to worker 4, gets routed to this pod, it's going to check if it already has it, and it will, and then it will in here, and it won't have to pull it again. So that enables you to more efficiently scale out and get better performance for your registries. So that's kind of why you want to use. So certain applications benefit from that, but not all. And the downside to this is if I were to benchmark these two, I can tell you with confidence that the RDB block would have better results than this file storage, because for its usability, I know that the like most file storage like protocols, they need to have provisions in place to let just to be able to handle multiple clients reading and writing to the same drive, and that's going to constrain resources, and they're not going to be able to get the kind of speed you see with block because of that. All right, now what's next? So when it comes to troubleshooting these kinds of things and improving it, so I have a cluster running on my Pi, and anyone who's ran K8's clusters on Raspberry Pis knows the next thing you're going to start doing now, if you're not just POCing stuff, like, because I'm an insane person and I try to self-host everything on these Pis. It's a fun challenge, I guess. I lose a lot of sleep from it, but the the next thing you want to do is make this stuff run better. So when I one thing about newer open source tools, CNCF stuff, etc., is the hell was that? Oh, that's trending. So Rook-ceph, you want to look at the GitHub, and there's a couple things you can benefit from. Oh dear, my dark mode. These CNCF projects will typically have any of these CRD readmes, and I know some of the people viewing this might know this, but I'm ashamed to admit how long it took me to know this kind of stuff, is generally maintainers have readmes that will go in depth on every single parameter that you can add into these into this cluster config. So the next thing I'm going to be doing is I'm going to meticulously go through this and find optimizations for my context, because they didn't design this. These default templates, they're not made for Raspberry Pis. We're just lucky that they work. Okay, so that's the next kind of thing. Some advice for making this kind of stuff work is, especially when you're pulling like latest releases. Most people in this industry, me included, we Google everything. If you're having a weird problem, you paste it into Google. With tools like this, it might not be indexed yet. So the first place you want to check are issues in Slack. You can't solely rely on GitHub for this kind of stuff. And some CRDs are good about this. Let's see if these guys are. Yes. You can do kubectl explain. Explain Ceph cluster. So the Ceph cluster object we added. So explain the Ceph cluster dot spec. Let's see if I can explain security. No, I can't. It's only the objects. So never mind. Some maintainers do a good job with this kind of stuff. If you do it like a explain pod, yeah, dot spec, you can see this is all pretty and full of definitions. These guys aren't quite there yet. Not all maintainers do this, so disregard. But just a tip for other tool sets you use. And yeah, anyone doing this, please let me know. Go ahead, you can give me a follow star on GitHub or what have you. You can ask me anything in the comments. I mean, this stuff is Not a lot of people are doing this. Expect things to break, but that's part of the fun. And yeah, enjoy.